Right. So let's get started with Terraform. Like, what is Terraform and how it is helpful? Just a second, 1 second. Uh, I actually opened the wrong page. Okay. So let us talk about Terraform. What is Terraform and how it is helpful for us? If you see our pipeline, we have created a pipelines, right? CI/CD pipelines. So if you see there, like we were, whenever a commit is happened on the GitHub repository, it is pulling the code, building it, testing it, executing the unit test cases, then creating the artifact, storing the artifact, and the artifact is stored, and then deploying it as a standalone container or in the production cluster, depending on the use case. This is what is happening. But if you notice there's a manual intervention where we are manually creating the instances. Like we are creating the build server, right? We are creating a EC2 instance, the build server. We are creating the EKS cluster. Manually, we are creating there and then we are executing the pipeline. But what if we can automate this step of provisioning the infrastructure, like creating the EC2 instance, creating the So that is what a Terraform does, infrastructure provisioning. And how is this infrastructure happens in Terraform? In Terraform, infrastructure happens via the code. It implements the concept of IAC. IAC means infrastructure as a code concept. Infrastructure as a code means still now people write the code for developing an application. They do write the code for testing. Here, writing the code for provisioning the infrastructure is nothing but infrastructure as a code. Means you look at the infrastructure in the form of code. You manage the infrastructure with the code. Your infrastructure would be represented in the form of code. That's what is IAC concept, infrastructure as a code. The most important concept in the DevOps. So we manage the infrastructure with the code. What are the advantages of it? The advantages is, yes, when you manage it with respect to the code, you can version control it. You can manage the different versions. You can create the infra, you can modify the infra, you can replicate the infra to another environment, you can scale the infra. All of that can be done with the Terraform. It's a tool for building, changing, and versioning infrastructure safely and efficiently. Is an open source and uses declarative language. It helps in infrastructure provisioning. It uses infrastructure as a code. Infrastructure code is written in HashiCorp language, HCL. So HCL is a HashiCorp language. That's a, provider of a Terraform, and it's a open source and it uses declarative language. And we have the format and the complete examples available in the official documentation, which we'll leverage to create ours. So this is what Terraform does. When we are talking about Terraform, there is another tool which overlaps with the Terraform and which causes confusion, which is nothing but Ansible. Ansible is a configuration management tool. Terraform is an infrastructure provisioning tool. What is the difference? Terraform is used to create the infra. Once infra is created, Ansible is used to configure it. Like maybe if you want to install any packages or any users, all of this would be taken care by Ansible. That's how they are different. But there's a lot of confusion because there are areas which overlaps. Means even Ansible can be used to create the infra and Terraform can be used to configure. Means they can also do the vice versa. But the major strength of Terraform lies in provisioning, whereas Ansible is to configure the infra. That's how they are different, right? So Ansible is more mature. It's a very old tool than Terraform, but by the time I created this presentation, Terraform was new. But now Terraform is also quite old and it's matured enough to provide the infra, and it's very widely used in the real industry, in the real world. So both are good tools and both use the concept of infrastructure as a code. But which one to use? Again, people will have question, which one to use? Here, you should look at these tools as two separate categories. One is for infrastructure provisioning and then one is for configuring. Means a combination is the greatest one in the real projects. So combination should be used always. Any questions in this part, till this part, from anyone? Before we dive into the architecture, is this much clear? Okay, if this is clear, let's get to Terraform. Terraform is a very simple yet powerful tool. It has got, the architecture has got two main components. One is core and the other one is providers. Sorry. Core is the main important component. As the name says, that is the core component or the very important component in Terraform. It takes two inputs. One is Terraform configuration and the other one is Terraform state file. It takes two inputs, state file and the configuration file. State file is nothing but which represents the actual state of the infrastructure. Like you have two servers or three servers. What is the actual state? Whenever you create the infra, automatically a state file is created, which will have the actual state of the infra. Terraform configuration file is what users, as a user, I write the Terraform configuration file. So that will have the expected state. Means I want to have four EC2 instances. All the expected results goes into the Terraform configuration file. Now core, okay, configuration file will have expected state, state will have the actual state of the infra. Right now, whenever you want to apply Terraform, these two are taken as the input. Right, core and the state files are taken as the input. Sorry, state file and the configuration file are taken as the input and they are compared, and then it will be deciding what to do exactly. Means let's say already three infrastructure, I mean three EC2 instances are there. As an expected state, you need four. So only one more is to be created, right? So that is the plan which Terraform will create when you apply Terraform. Okay, plan is like a Terraform plan is like a document which will have what to be done to achieve the expected state, right? So that's how you have the Terraform plan created. And then this Terraform plan will be applied by Terraform. And then Terraform applied means it should create that infra. But how does it create the infra? Then comes the second most important component called provider. Provider is the one which takes inputs from these components and create the infrastructure. There are so many providers like AWS provider, GCP provider, Kubernetes and so on. These are all the providers which makes the state, or else these are all the providers which will help you achieve the actual state. Right? Provider is like an API, a program which will give access to bunch of resources of that particular API. Means it works with the Terraform API, I mean AWS API, Kubernetes API and so on. Let me show you those providers. If you see here Terraform providers, see these are all the Terraform providers. If you go to the official registry for Terraform, you can see all the providers. Providers are a logical abstraction of an upstream API. They're responsible for understanding API interactions. Terraform will provision the interaction by interacting with the AWS API. So many providers are there. If you want to automate infra on GCP, it's Google, this provider you have to use, or Kubernetes provider and so on. There were so many providers available. Provider is like a program or a software or executable, whatever you call it. If you go to a particular provider, you have a clean documentation of what it does. Lifecycle management of AWS resources, including EC2, Lambda, EKS, ECS, all of this is done by this provider, right? How to use the provider? This is the block of code which uses provider. right? How to use the provider. To install the provider, copy and paste the code into Terraform configuration, then run the Terraform in it. We'll look into it, but that's how you use the provider. Whenever you install the Terraform, you don't get all these providers by default, right? Because if you get all these providers by default, it makes it too heavy, right? These are executables or programs, so it makes it very heavy. So it doesn't come by default with all these providers. You have to install the provider later on by using this block of code, right? So we have to install whichever provider you need. If you know working with one provider, other providers are same. Okay. And see, these are all the different providers. And coming to this documentation, here is the documentation of what it does and all. See, Terraform comes with a great documentation. Again, it is like where you can refer when writing the Terraform configurations. This is the reference we'll use, right? So those are the providers, something about the providers. And so this is how the architecture is. State file, which will have the actual state, configuration file, which will have the expected state. Both of them will be compared and Terraform plan will be created. And once Terraform plan is created, it will execute the plan using the provider. That is the complete flow and a simple architecture. Any questions from anyone in this part before we proceed? So if this is clear, if the architecture is clear, can go with the setup.
Yeah,
Terraform
ma'am,
is
this Terraform and Ansible, this is two different tool or in top of Terraform, we can configure the Ansible. We
two
can,
different tools.
okay, ma'am. So
Terraform
this
is
is,
used for provisioning the infrastructure. Ansible is used for configuring the infra.
so this is for fully automated, for CI/CD pipeline, right, ma'am?
To create the infrastructure, not to automate a pipeline, to create the infrastructure, this is used. To create
Infrastructure means, whichever, Git and this
EC2
deployment.
instances, EKS cluster, your infrastructure. Infrastructure means your servers, your load balancers, your lambdas, your database. This is your infrastructure.
Okay.
It will help you create your infrastructure automatically.
Okay.
Till now, how are you creating your EC2 instance? You are logging into your AWS account, you go to the AWS management console, you search, you go to the AWS, EC2 dashboard, then you click on launch instance, you create it, right? Those steps can be automated. That's a manual step we have in our pipeline. We are deploying something on the EC2 instance, we are building on a build server, but those are created manually. But now Terraform can be used to automate them. Okay, Terraform works on multiple operating systems. You can install it on Windows, Linux, Mac. So let's get started and let's set up this Terraform to proceed with the hands-on. So you may choose some EC2 instance and then install it there. Or else I would like to install Terraform on my local machine and automate creating infra here. So let me log in. So if I want to create some infrastructure, let's say you remember build server, right? In our pipeline, we need build server, we need Jenkins server, all these EC2 instances. How do we create them? Just go and click on launch instance. These are the steps you should go to: provide the name, provide the AMI, provide the instance ID and all, and then launch instance. So those steps can be automated, whichever needed for your pipeline, right? That is what we'll do. So first, let us install Terraform. You can install Terraform on multiple operating system, like I told you. Install Terraform. Here are the steps. Official documentation. See if it is Windows or Linux. Say Linux, CentOS, Fedora, Amazon Linux. Okay, and then FreeBSD. So see, these are all the operating systems. If it is Linux and if it's Amazon Linux, you can go here, or Fedora type and all. Depending on your distribution, you can select it and run those commands. For now, I have installed it on Mac. So I would like to try this on Mac. I have already Terraform installed here by following those steps. Terraform version. Okay, Terraform is installed. This is the version I have. That's fine. Now, okay, let us let us use Terraform to provision the infrastructure. Let me create some folder to start with. One second. See, you can also install this GitHub Copilot. I'm seeing it, code completions. Huh. Copilot, not GitHub Copilot. The chatbot, AI tool, right? Terraform for, even I'm trying this here only now. Just now I got this plugin enabled here. Right, Terraform for EC2 creation. Put the prompt properly. Here the Terraform configuration. Right, you get everything here. You don't have to struggle to write this Terraform code. And also this is not called development or coding. Okay, this is the configurations you use. Save the file as, then what commands you need to run. Everything is very clear. Do you see that? But when you are learning it, don't use it. Okay, because you will not know what it is at all. All right, come to our project, create some Terraform config file called main.tf. Okay, now you want to write Terraform, right? First of all, okay, Terraform is installed, but you need to tell which provider you want to use, isn't it? There were so many providers. I want to automate infrastructure in AWS, so I need AWS provider. How to use this provider? Here is the block of code. Just copy it, and this is what you have to use. Copy from here and place it. Even it should be available here also. See here, it assumed provider is installed, but this is the code block to install the provider. HashiCorp AWS means it will install this provider with this version. Okay, so now what you have to do, I have returned the Terraform provider. To install those providers, Terraform init. That's what is given here also. Run Terraform init. What it does and all it shows. Terraform init will initialize Terraform by installing the provider. So let us run this command. Say it's installing the provider, the backend plugins. Okay. So So you can see the Terraform has been successfully initialized, and you can see in the same folder .terraform folder log file created. Log file is nothing but which will tell you the version of the Terraform you are using, right? It will tell you which version it's using kind of. Uh, okay, which version of provider you are using. And if you go to that particular folder, okay, so this is the folder, right? And if you see here, Terraform folder is created within that providers. Can you all see this? If you go to that folder, you can see it has installed this one. This is the executable. That's what I'm telling. This is the executable. See? So you don't get all the providers by default, but because they occupy some space. So you get this provider as you installed it. That's an executable which you'll use to interact with the AWS resources. Okay, that's what is shown here. All right, we have got the provider, everything ready. Now how to connect to AWS account? Isn't it? We need to connect to the account to create the instances. So if you just scroll down, uh, see provider and the provider region you can configure, and also you can provide the AWS access key, secret access key. What is this access key, secret access key? We have already seen this during our Docker sessions, right? So those are the credentials you have to configure in the provider block. Here is where you can provide these details. Like I want to create the infra in AP South 1. Okay, and the access key, secret access key. But if you provide access key, secret access key, it's not secure. Rather, what you can do is in your machine, wherever you are running, you have to install AWS CLI and run AWS configure. See, I have already added those, so it was showing those details. So that is fine. Now you can able to create the infra, right? So that is all we have very simple of comparing, I mean, getting the Terraform ready with the provider details and the install the provider, whatever you want. Now, if you want to create an EC2 instance, let's say I just want to create some EC2 instance, we can go ahead writing the code. Yeah, let's get started. Okay. Before that, one more thing. Here we are going to write our Terraform configurations, right? You may have to version control these with the Git. And also, I don't want certain files to be version controlled. Do you remember we learned Git ignore? But this is the practical real use case of Git ignore. I don't want to version control this .terraform files, right? That's a provider. I don't have to, that's an executable. I don't have to push that onto GitHub. So I will add this directory Terraform, right? So that it will not version control this particular folder anymore. Let me do git init now in the same folder. See, do you see that this is grayed out? This is not version control. Perfect. It's working as expected. You can add, commit, and push this code to GitHub. All right. Now come back here, and I would like to create an EC2 instance or whatever, or an S3 bucket. What is an S3 bucket, by the way? You may create any resources on AWS, right? Let me introduce something else called S3 bucket. S3 means simple storage service where you can store any files, any data can be stored here. Let me just clean up them. Already some buckets are existing. Those are the names I have given to my bucket. Only once a name is given correctly, you can delete it. Okay, so you can create a bucket and store some data. So, but how do you create a bucket? Click on create bucket, give all these details and create it, right? Or else you can go with AWS instance also because you are well familiarized with that. So, let's say I want to create an EC2 instance. Go to EC2. You can search here for those resources. See here, you can see AWS instance, some resource. Okay. See, it will show you all the code, what you have to use. See, this is what you have to use. So let me copy this. So what is this actually? Resource definition, resource, type of the resource, some name. Let's say I want to give the name as web server or web. Okay, and then the AMI. Ignore this. You have to provide the AMI details. Right, and then instance type I want T2 micro. We are creating from the UI, but here tag name I want to put as hello world instance, something like this. So that's all are the minimum details you have to provide. So if you just click on launch instance, what is the AMI you provide? AMI ID is nothing but Amazon mesh image. When you choose here, it will show you the AMI ID. So you can use this AMI ID T2 micro instance. That should create you the instance. Am I making sense? That's all. That will create an EC2 instance instead of you going through all those steps. How do you do that? Terraform init already we have done Terraform plan. That's what I told you, right? It will take, this is the Terraform configuration file and there is no actual infra as of now. It will evaluate what are the steps to be done to create this infra. See, it tells you one resource to be created and these are all the parameters it will generate once it is created. Plus indicates it's going to create this infra. Okay, now it just tells you what it will do. Now Terraform apply will actually apply the changes. It will ask for confirmation. You have to provide yes so that it can proceed. This is called actually the Terraform lifecycle. See, it's creating. It says it's creating. Let's wait. So one resource to be created. It tells you one resource to be created. And this is the state file. Whenever it applies, it will create a state file automatically. This is what we are talking during the architecture. This is the most important file which will have all the details of the infra. And again, this should not be version controlled because it has all the sensitive data. So I want to ignore this as well. You can place it also here. I want to ignore that state file will have the current state of the infra. So anything that has state should be ignored. See, do you see that got grayed out? Perfect, right? So those files are not version control. That's the practical use case of git ignore file. All right, now infra is created, state
Uh,
there.
Preeti, I did not understand this version control. What exactly is? Can you come again?
Git is used to version control, right? Git
Yeah.
version control. So I'm version controlling this Terraform config files.
What does this exactly mean? I didn't get you.
Do you know Git, right? What is Git used for?
Yes,
What is Git used for?
versioning.
The same thing. I'm versioning this file. This is also file, right? TF file.
Yes,
I'm version controlling
but
this file.
you said you are ignoring it, right?
Ignoring Terraform state files. You understood what is
So,
version controlling, right?
but you said it will check the current state away from the state file, right?
See, let's don't mix up. Do you understand why I'm using it here?
For controlling version of that main.tf file.
This is for maintaining this. Whatever in this project, this entire project, I'm version controlling with Git, right? So in this folder, there are some files which should not be version controlled. Why they should not be version controlled? Terraform, this contains executable. This need not be version controlled. I don't have to push that on GitHub. Similarly, state file, it has sensitive data. I don't want to version control and push it on GitHub. So whichever I don't want to version control, I'm adding them in a git ignore. That's a git ignore concept, right? We have learned git ignore.
Okay, okay. So these are sensitive data. That is why you don't want to push them to Git.
Yes.
That is why you are ignoring it, right?
Yeah. Yeah.
Okay,
One
got
is
it.
because it's executable. Another one is because it has sensitive data. We learned git ignore already, but with the dummy files. Now this is the real use case of git ignore. Okay,
got it.
so state file will have all the details of your infra. If you want to see any details like IP address, whatever, you can go through this JSON file and check that. Or else there is a command where you can check the state. Make sure you are using the bash terminal. G shell will not support all the Terraform commands. Okay, now Terraform state list. This will show you what are all the resource it has created. See, it has created a resource called web, which is of type AWS instance. I want to see all the details. Terraform show that particular name, type of the resource and name of the resource. Instead of going to the JSON, it will show you here. Show Terraform state show. Command is state show. State commands. Okay, it will show you all the details in your terminal also this way. Okay, that's how state can be used, state commands can be used. Okay, first let's see if the infra is created here. On the AWS console, let's go to instances. Yes, of course. Do you see this? Instead of you creating manually, you have the infrastructure provision. It's in running state, it got the private IP, public IP, you can use them and all. Is that making sense, everyone? State commands are to check the actual data of your infra. Instead of going to the state file, you can check here itself. Right? And let's say I want to modify the infra. Yes, you can modify it. Okay, first let me ask you one more thing. Already infra is created. I'll run the apply command again. What happens? Will it create again another EC2 instance?
It will check with the state file which is already existing and compare it with the main.file.
Exactly. So it will compare the state file with the main file because there is no changes. It will not. Means it will not redo the things. This is called idempotency. The fancy term given to this is called idempotency. Means if it already in state, it will not do any changes. Right? That's called idempotency. All the infrastructure as code tools uses this concept of IAC. Okay. All right. Now let's say, okay, fine. But I would like to make a modify. Let's say Terraform server. So TF5. I want to put this name as a display name. Now, before applying, I just want to show you Terraform plan at this point. See here, tilde indicates updates, modifications. So it tells you very clearly, name is going to be changed from hello world to TF1. Then apply it. It will ask for confirmation. Give yes for confirmation. It should apply the change. Instance is same. See, that's why it's saying 0 to add. It's not creating anything. 1 to change. It's not destroying anything. Just 1 to change. Means one resource has been changed. Now you can see. Do you see the name got changed? Means you can modify the infra, right? You can modify your infrastructure and what other details you can see. Okay, let's say I want to scale the infra. You have something called meta parameter called count. I'm sorry. Count a meta parameter. See, I just want to create two EC2 instances. You can do that. That will create two. Also, I would like to prefixes. See, it auto text, auto completion is working. I want to name it as, I don't want web. I just want to name it as count provides index parameter. Index starts from 0. So if you want, you can put like Terraform 0 or you can put as Terraform 1, 2 and so on if you want. Now again I'm applying. Now one should be modified, one should be created, right? Existing instance should be modified with the name, a new instance should be created. That's what it should show in the plan or else here also. See, it's creating it. Also modification should be there. Why it is not modifying? It's one to add, one to change. Did I save it? Terraform. Oh, already one is a TF1 already there, right? We don't have to modify it. Okay. One to be created. That's how you can scale your infra. Instead of you creating it, it's reusable. See, new one is getting created. You see, it's in pending state. Terraform 1, Terraform 2. Actually, index starts from 0. But if you want to give the actual number, that's why I'm adding +1. If you want to see what's happening, state file can help you see all the details. State file will have all the details. There is one more file called state backup file, right? State backup file will have the previous state of the infra. And if you want to see the infra, Terraform state list. Terraform state list. Okay, say two instances. So it was showing two. Whichever details you want. Terraform, state, show. Instead of going to the state file, if you want to see that in the terminal itself, you can see 0 means first instance. So that's how you can see the details, right? So we have seen modifying the infrastructure, scaling the infrastructure, destroying. If you want to destroy, this is called Terraform lifecycle. Terraform will destroy the complete infrastructure. This will destroy the whole infra, whatever you are having. And see, deletion will be shown with a red minus, indicates it's deleting, it is destroying. See, destroy. Minus means destroy. Confirm with yes. It says destroying. And see, one is they're all shutting down. Do you see that? Perfect, right? It helps you to provision your infrastructure at any scale. So it says destroyed because it is destroyed. If you see state list, it's blank because no resources were there in the state. And also you can see state file is a blank, right? Whereas state backup will have those two infra, right? That's one way to create the infra. Again, I'm creating it, Terraform apply. If you don't want the prompt to wait, you can give here itself as auto approve. So that it will not wait for your prompt to give yes. It should create the infra back. Right? That's a complete life cycle. Creating, modifying, scaling, deleting. So plus this is two resources were created, and again you can see state list and all. But let's suppose I just want to get the IP address of the instance, public IP. I have to go to this management console, this AWS console, right? But it's not always possible to go to this console this way. We may not have access to this console. So if any parameters, if you want to print it, of course, state file, you can see state commands you can use. But if you want to get here, there is something called output. Do you see that? Output, name, some name, like let's say IP. I want to get the public IP of the instance. See, that's all. See, actually, this is an object. Okay, let me write here. AWS instance, when you give dot, it will show you what are all the objects it has got. Again, array means it shows the index number, like it starts from 0, first, second, and all. I want to see all the instances public IP. When you give here dot, this dot, it will show you all the properties actually of these objects. So out of which we can choose that public IP. So that it should print the public IP. Let me do apply auto approve. It should print both public IPs. Do you see that? Or else if you want only one instance, first instance public IP, because indexing starts from 0. That's how output values work. Output values will help to print something from there. See, this is the one. Right? Is that making sense? Output value will help you get some data of your infrastructure and print it in your terminal, in your console. Is this clear? Any
You are
question?
just yeah. So in this, you are taking AWS instance dot web star dot public IP. So when we look at the above resource, AWS instance web, you do not see any public IP. So it is taking from the Terraform state file.
From the state file, yes.
Okay.
All this information is present in the state file.
So from here only it is taking fetching all
This
the
is
values.
the public IP. Yes.
Okay.
These are all the properties you can grep using output values. Whatever in the state file, see public DNS, region, root block device, all these details you can print using your output values or tenancy, timeouts, volume tags, anything you can get all this information.
Ma'am, these are the default, values, right?
Right.
Is it possible to change manually anything if I want to?
File should not be manually modified. When it is creating instance, it is showing you the details, it's getting you the details. This should not be modified manually, state files. All of those you can grep here. It will print private DNS of the instances. Do you see that? Whichever in the output, in the state file. Okay. So this is one thing. Using output values. And you can make your code better. If you see here, this is hard coded, right? This ID is different with different regions. AP South 1 ID is different. In US region, ID is different. Also, this ID keep on changing. They may be making modifications to your to the AMIs, new AMIs might be coming up. These IDs will not work. So you should not hard code them, rather grep them dynamically. So how do you grep them dynamically? That's where comes something called data sources in Terraform. If you search here, you will see AWS AMI. Also search under data sources. See, there is a data source AMI. See, data source AMI, grab something by passing the filters, like which type of AMI you need, which type of root device type you need, which type of virtualization you need. Whenever you start creating your instance, here are all those details. See, virtualization HVM, enable true root device type and all. By providing those filters, you can filter out and get the latest AMI. Right? So data sources are the blocks which will help you fetch the details from the AWS console. Let me write the data source here to grab the AMI instead of hard coding it. See, data source AMI, name is latest Amazon, most recent ones I need, owner is AWS. Filters are, I just want to Amazon Linux too, then that is the filter. But now this is a different name it has got. It's not Amazon Linux too. You may also get those names using this AMIs. All the AMIs will be listed here. We can get the public images, the latest ones. You can pass different filters here. 2023 is the latest one, right? See, these are all relevant to 2023, but some name you can choose here. These are the names of the instances. Just searching what other filters we can provide. 2023 we are providing. Let me give this ID. We already have this ID. Right, see here. It starts with AL 2023 kind of. Okay, let me just add this. Oops. It's not Amazon Linux 2 is not available now, so the name is like this. Maybe if I want to grab a latest one. Right, it should grab the AMI. Also here the version. I just want to give here. It could be anything. Versions may change, but it should be kernel AMI AL 2023 kind of. Let's see if it will grab this. This is the data source. That will grab the AMI. Now, instead of hard coding it, how do you use it? AMI equal to, see, it shows you data dot. When you give the dot, it will show you what is your type. AWS AMI type dot the name of your AMI, the name of your data source. This is the name of our data source. So dot latest. That's all. That will grab the AMI rather than hard coding the AMI. So this is, we are making our configurations better. Nothing hard coded, it will dynamically pull us. If it is pulling the right correct AMI, this one, it should say no changes, right? So let's see. If it is pulling up a different AMI, then it should show us some changes. It's pulling a different AMI. That's why it was terminating, destroying, and it's already doing because I did auto approve. Right, means we have to modify this filter a better. It's not grabbing the AMI we need, rather it's grabbing something else. Got it? So make sure we put this filter correctly so that we'll grab the AMI what we want.
See, in this, why are you mentioning only data block? I mean, why are you mentioning inside data block only?
Huh? Come
I mean,
again,
in
please.
this, yeah, in this case, why are you mentioning inside data block only?
Why are you mentioning inside GitHub?
Data block.
Data block. Are you saying data block?
Yeah, yeah.
Data block is to grab the data from your AWS. See, if you keep your cursor, it tells you data block requires the Terraform read from a given data source and export the result under the given local name. The name is under refer to this resource, means it's grabbing some data from AWS and store it in this name. Resource type name. Later on, instead of hard coding this, I'm referring this data source. So because the AMI is stored in here. So data dot this name dot this one dot id means AMI ID is assigned to AMI instead of hard coding. Data block, those are called data sources, are used to fetch the data from the AWS console. We want to grab the AMI ID, right? How do we get the AMI ID? Is this clear, everyone? So it has grabbed the AMI automatically and it was using it. Phi BD. So it's having this one. Let me put this filter. I want to grab the one. So search for something like this. See, there are so many things that are matching. It is matching with this also. So we should be more specific. Kernel star x86. It might have created the instance. This is the one. Let's check what AMI it has used. It has used this one. See, all of this is matching with this pattern, right? Means we should choose something else. It's matching with this. Minimal. It was using something minimal, but this is the one I want. So we should modify our filter a bit. So AML hyphen 2023. Maybe we can put this as well. Hyphen 2023. AMI hyphen 2023 dot something. Maybe we can try with this so that it should return this YBD. Let me reapply. It depends on which one we choose. And let's see which instances it was creating. It has chosen the right one. Do you see 5 ED, whichever we want? So that's how you have to adjust your filter to choose the one you want. Right, that's a data source to fetch the data from the AWS console. And output values we have seen. Any more questions from anyone in this part? These are data sources, output values. This is resource definition to create the instance. This is to print the output in the console. This is to grab some values from the AWS. And what else we can do? See here, instance type is even hard coded. You can pass them during the runtime. You can pass the values, right? So you can parameterize them. How do you do that? You can define the variable first using a variable block. Variable instance type, instance type, right? See, default value we can assign, okay? And here instead of hard coding it, var dot instance type, so that it will take value from here. Let's suppose I don't define the default value. Then from where it would take the value? How would you pass the value? We'll see that. First let this apply, then we'll see this. See, var dot instance type. You should pass the value. And how do you pass it? You can pass the value in multiple ways. We'll look into one by one. Okay, two destroyed, it says, and it has created two. Okay, now let's suppose now I want to apply it. Terraform apply. It will wait for the input. It will prompt. Here you have to give the value. It will wait till you give the value. That's one thing which is not suggested in the real practice. Another thing is you can pass the value this way. Minus var and the values. From the runtime, just pass the value. Var equal to instance type equal to t2.micro. Because it's same, it should say no changes to be applied. That's another value where you don't have to wait for the means your prompt need not wait for you. See, done. That's one way. Another way is instead of, even this is not a feasible in reality. What you can do is you can create a file called terraform.tfvars and define the values here. This is the best and the right way. t2.micro. That's it. Right now you don't have to provide it here, or it doesn't wait for your prompt. It can just take the value from this file. Actually, it should be given in the quotes. Okay. Right, done. So that is always the right way. If you put it in terraform.tfvars, yes, it can identify this file and get the values. What if you want to use a different set of values? Terraform dev.tfvars. You can have a different file, right? Instance type equal to T2 micro, T2 medium, depending on the environment, it might be different. If you run this, it will take only from terraform.tfvars. If you want to pass from another file, there is an attribute called Terraform var file is equal to Terraform dev.tf files, so that it would take from that particular file. And why is this needed? Where do you have to provide this Terraform, means different variables? This comes into picture when you replicate your infrastructure. Means let's say I have my infrastructure for dev environment. I want to replicate it for test environments, right? Or prod environment. Same infra, same code. That's where these different type of variables files will help. Tomorrow we'll deep dive into that part of replicating the infrastructure. We have seen data sources, output values, and how do you pass different values to your variables. We'll look into replicating the infrastructure in the next class. Any questions from anyone from this part? Until here, any questions? Any questions from anyone? All right, then we shall close here, but make sure you destroy the infrastructure before you move on. This is right way to destroy. Even destroy will wait for your prompt, so you can also use auto approve for destroy command also. Otherwise, it will wait for your input. It will give you a prompt and wait for your input.
Ma'am, we can stop also, no? Rather than destroy.
You want to go to AWS console and stop it?
No, here, is there any command to stop here?
This is to create the infrastructure. You can stop the infra, but this is not the right way. You have to use Ansible there. If you want to manage your infrastructure, configure it. After some time, if you want to stop, that is to be handled from Ansible.
Oh, we cannot stop from here. Okay.
To clean up, this is the better way so that it will terminate everything as well.
Ma'am, why can't AWS is not handling these things also? This infrastructure.
Thanks.
This like Terraform we are using for infrastructure, right?
Mm.
So, why can't AWS is not handling this? This why? Or AWS also has some services.
AWS is a cloud platform. You can
Yeah.
manage, you can create your infrastructure on AWS. AWS is not an automation tool to create it. AWS is a platform where you can have your infrastructure. You want AWS to create infrastructure itself. That's where tools like Terraform is there. It's a cloud platform. It's not an infrastructure provisioning tool or automation tool. If you are talking about some services which can automate infrastructure, yes, there are services like cloud formation on AWS. Cloud
Right.
formation, cloud formation is there which can provision the infrastructure, but it is bound to only AWS. What if you want to create infrastructure on Google Cloud? That will not work, right? But Terraform will work to provision the infra on any cloud. So Terraform is more widely used and is more demanded one in real time rather than cloud formation. Concept is same. IAC both uses similar concept. Got it? So
Nice one. No,
already.
ma'am, like if we are continuously using AWS, like,
Mhm.
so why can't we use that AWS service only? Like,
In the real world, they use different clouds.
in the real world, right, ma'am?
Mm.
See, if you are using AWS services, right? So,
In real world, AWS is not the only one that is used. They use multiple clouds. Okay. Also, cloud formation has got its own limitations. It's not so stable and mature like Terraform. Also, they have hybrid clouds. They'll be using Azure, GCP, AWS, all in combo. Then cloud formation will not help in that case. Again. All right. All right, then we'll close here and we'll continue tomorrow. Thank you all. Good day. Bye, everyone.
Thank you, ma'am.